begin with, we're going to be exploring the UAS composition. Now, UAS is uncrewed aerial systems, and an uncrewed aerial system is made up of many different components. So to begin with, as we see on the screen, we've got the UAV, and that is the uncrewed aerial vehicle. This could also be referred to as a drone. Now, we're going to be exploring each of these different components in more detail in a second, but first, we're exploring it at a high level. In addition to that, we've got the UAVC. Now, the UAVC is a UAV controller. This is a remote control or a ground-based station which is used to control a specific UAV or a set of UAVs. In addition to that, we've got a USS, and this is the Uncrewed Aerial System Service Supplier. Now, the example we're going to be using throughout this course is a UTM. And this is an Uncrewed Aerial System Traffic Management. And that will manage traffic of multiple different UAVs and support the reduction in collision between these UAVs and what we call DAA, that's detection and avoidance. Now, we've got all of these different components of the UAS, but they also need to communicate with each other. And that can be done through the use of a 5G system, as an example. So the UAVC, that UAV controller, can communicate to that UAV through the 5G system. It can also communicate to that USS as well. And there are multiple different ways which this can be applied, and we will explore that within this session. Now, as we can see on the screen, we've got our 5G system, and that's composed of a radio access network. And within that radio access network, we're going to be having cell towers, or these G node Bs which exist. We've also got our 5G core as well, and we'll explore that in more detail later on within this course. Ultimately, what the 5G system allows us to do is it allows this UAVC, the UAV, and the USS, which could be that UTM, to communicate with each other, utilising that 5G system. Now, what we can have as well, utilising 5G, is direct communication between the UAVC and the UAV. We'll explore how that works in more detail, and that's using the PC5 reference point. So, let's zoom in on the UAV and explore that in more depth. Now, UAVs have a range of different categories, and this is because UAVs can come with a range of different features. So, UAVs could be equipped with GPS, they could be equipped with LiDAR, light detection and ranging, for example. They could be equipped with 4K cameras. They have a range of different functionality and are extremely flexible in how they can be applied. But within the United Kingdom and the European Union, we apply 3 different categories to UAVs. To begin with, we have the open category. And the open category consists of a range of different maximum and minimum requirements. So we can see here that the drone has to have a maximum weight of 25 kilograms. We can see that it's only allowed to be flied within what we call VLOS, and that is the visual line of sight. It's a maximum height of 400 feet above the ground, and we have a 1-to-1 ratio of pilots, or UAVCs, to UAVs. So 1 UAV controller to every UAV which is being utilised. There's also flight restricted areas which will be applied as well, so we're thinking of things such as airports, for example. In addition to that, we've got the specific category. Now, the specific category requires or will allow BVLOS operations, and this is beyond visual line of sight operations. So this is where this UAVC will be controlling this drone beyond their visual line of sight. We are allowed to fly above 400 feet within the specific category. The pilot will require a GVC, and this is a general visual line of sight certificate, and operations in congested areas are allowed as well. Finally, the last category we've got is the certified category. Now, within the certified category, we can see that the aircraft needs to be certified, or the drone which is being utilised. The operator needs to be certified as well. The pilot requires a license, Now, when we're referring to the pilot versus the operator is the person that owns all of the equipment. The pilot is the one that is actually currently utilizing it at that time. And finally, depending on the type of flight which is being utilized, a risk assessment may need to be provided. Now, this is only for very specific scenarios, so we could be applying a continuous route that we are using for our drones, in which case that aircraft needs to be certified, operations and pilots need licensing as well. So this could be for entertainment purposes. We could be using our drone on a predefined route. We've identified a risk assessment process which can be applied to that, and we specify this is the level of risk of us using this route on a continuous basis. Now, on top of UAV categories, we also have what we call open subcategories. So we initially explored the open group of UAV categories. Within that, we have 3 different subcategories, which are A1, A2, and A3. So A1, as it specifies here, permits flights over uninvolved individuals but prohibits flying over large gatherings. So we'll have a specific category of drones which are going to be residing within the A1 subgroup. Now, it says here that this is applicable to drones under 250 grams, and this, it says in brackets, the C0 and C1 class. We'll be exploring those classes in a second. So operators must register the drone if it has a camera. However, a flyer ID is not required. Moving on to the A2 category now, we can see that this allows flights near people, and we're maintaining a minimum distance of 30 meters, or 5 meters in a low speed mode for these specific drones. We've also got some classifications here, so C2 classification, which correlates to the A2 subcategory. In addition to that, the pilots will need an A2C of C, and that is that certificate of competency, saying that they're actually able to fly this drone to a specific level. And finally, we've got the A3 category. Now, this requires operations to be conducted at least 150 meters away from individuals or residential areas, for example. So what we see here is this is applicable to drones that are up to 250 kilograms, and these are within the C3 and C4 classes of drones. Now, let's have a look at those specific drone classes as well, still encompassing UAV. So here we can see on the screen we've got the C0 class, and C0, we're specifying that the takeoff mass of these specific drones are less than 250 grams. We can see the maximum speed has to be less than 19 meters per second. It can have optional geographical awareness, so it may have GPS implemented, it may not. And we can see that that is operational within the A1 subcategory. Now, moving on to the C1 class of UAVs or drones, we can see that the takeoff mass is less than 900 grams. We can see that they are required to have some form of geo awareness, and they can also support low sound level, and that's to reduce noise pollution. These also reside within that A1 category as well. Next, we've got the C2 category. So this is drones or UAVs that weigh less than 4 kilograms. These are required to have geographical awareness. They also have obstacle avoidance, and they can support low speed mode. So that's where we were discussing previously about the A2 category and how drones can be flown within 5 meters of people if they support that low speed mode. Next, we've got the C3 category. So this is drones that are less than 25 kilograms. We've got geographical awareness once again, and they can support autonomous flight. So this is no requirement for a UAV controller for that specific UAV. Now, the operational subcategory we see here is A3. Finally, we've got the C4 category. Now, the C4 category is also specifying drones that are less than 25 kilograms, but they don't support automation and they do not have geographical awareness. And they are operating within that A3 category as well. So these are the 5 different classes which are utilised for UAVs within the UK and within the European Union. Now, moving on from that, we're going to be looking at the UTM or the USS. Now, remember when we looked previously at the uncrewed aerial system composition, we saw that we've got our UAV, we have our UAV controller, and we've also got the USS, and that is that UAS service supplier. Now, one example that we used was the UTM, the UAS traffic management. And that traffic management is a system of systems. It's made up of a wide range of features and capabilities. And it's actually utilized by a wide range of stakeholders as well. Now, who may want this information from a specific UTM? Well, we've got the drone pilots. They're going to be requesting information from the UTM which supports the location of the drone they may be flying if it's beyond visual line of sight. And we need to think about this drone may be containing cameras which are being utilized. That information could be sent to that UTM, and the UTM could be sending that information down to that UAV controller. Because if we're beyond visual line of sight, we may not have direct communication to that specific drone. On top of that, we've got the operators as well. Now, we discussed the difference between the pilots and the operators previously, and the operators may be there to be collecting a large range of information about all of the drones or all of the UAVs which they own and maintain. Now, this could be for that detection and avoidance based information. This could be to support and identify that the drones or the UAVs are taking the specific route which is meant to be utilized. They can be taking a lot of different information from that UTM. In addition to that, we've got conventional aviation pilots as well. Now, obviously drones are going to be taking up and utilizing airspace. We've got conventional aircraft which are going to be utilized as well. And conventional aviation pilots and conventional aircraft themselves can be querying that UTM to identify the location of specific drones. So this supports that detection and avoidance as well, but from an aviation perspective. In addition to that, we've got law enforcement. Now, we could identify that a drone is operating within a restricted area, and law enforcement can query this UTM in order to support tracking the exact location of that drone. We've got emergency services as well. Now, emergency services may be utilizing drones, or they may require to identify the location of specific drones as well, such as the law enforcement agencies. So, emergency services could be utilizing the UTM in order to support navigation of their own drones and location tracking of their own drones for disaster response-based approaches, but they could also be doing it for tracking of drones in emergency situations. And finally, we've got supranational institutions. Now, what we mean by that is we may have specific operators, for example, or standards bodies, which are operating in multiple different countries. So they're going to be querying all of the different UTMs which exist within each of these different regions in order to collate all of the information around the drones which are being utilized and seeing if standards are being adhered to. So we've got a range of UTM stakeholders now. Now this is different people or different services which are going to be querying that specific UTM. Let's have a look at some examples of the services that UTM offers. So, in terms of functionality, we can see here a range of different features which are supported at the UTM. So we can support UAS registration, so that's uncrewed aerial system registration. So we can see here that UAVs, pilots, or UAVCs can register with that UTM. We have stakeholder example on the right-hand side of the screen, such as UAV entities or specific service providers. Now, we also have UAS identification. And so once a device is registered to that specific UAM, whether that be that UAV, whether it be the pilot, whether it be a specific operator, they need to provide a specific identification in order to request and retrieve specific services. So once again, as a stakeholder example, we see that as being the UAV pilot, the UAV itself, or the UAV operator. Now, the UTM can also provide geofencing information. And the example we can use for that is those conventional airspace users. The UTM is going to be there to collate and share airspace restriction-based information and UAV location-based information to other airspace users. That feeds into this real-time positioning as well. We can utilize real-time positioning to support specific locations of UAVs. And the example we used previously, and the example which is displayed on the screen here, is this can be utilized by law enforcement. Next, we've got operation and flight requests. So drone flight plans can actually be created and sent to the UTM in order to specify this is the exact path which is being taken. And this can be used primarily for autonomous drones. So we can see here that this can be stored at the UTM, it can be queried at the UTM, it can be adapted at the UTM, and also be deleted. So essentially what we're doing is we're providing intent to the UTM system, specifying this is the specific path we want to be following. Finally, we've got notifications, alerts, and warnings. So this is specifically designed for the UAV controller or that pilot, UAV pilot, and this is providing warnings or shared information to improve awareness for these specific pilots. So this could be weather alert examples, this could be traffic congestion examples in the air. Okay, so throughout this section, we've explored all of the different components of the uncrewed aerial system. We've explored in detail the UAV, that uncrewed aerial vehicle. We've explored the USS, that uncrewed aerial system service supplier, such as an UTM. We've explored the UAV controller, and we've also explored how it's going to be utilizing that 5G system in order to communicate with all of the different parties. Next, we're going to be exploring A2X, and A2X is aircraft to everything. So this is a functional model which standardizes communication between a range of different components that UAV can communicate with. Now, the 3GPP specifications for A2X, which are 24.577, really focus on utilizing the previous V2X, vehicle to everything standard. So that is 23.287. Now, everything we see in the A2X specifications ultimately just says, please refer back to the V2X specifications on how this is standardized. And one of those components, if we expand A2X, is the different domains which the specific UAV can communicate with. So one domain we have is A2A, and that is aircraft to aircraft communication. Now this is direct or indirect communication which has been standardized between the UAV and another aircraft. So this could be helicopters, this could be airplanes, this could be other UAVs as an example. In addition to that, we have A2I, and this is aircraft to infrastructure. Now, aircraft to infrastructure is referring to a UAV communicating to smart buildings or smart infrastructure around a city to support decision making. Now, this could be for collision-based decision-making. This could be for routes-based decision-making as well. This could be for congestion information. That can all be provided through communication to the infrastructure. Next, we've got A2P. Now, A2P can cover two different domains. A2P, which is aircraft to pedestrian, can cover safety-based information. So it can provide warnings to pedestrians about aircraft which are too close or UAVs which are too close. It can also support the UAV side of collision detection as well. But it can also be used for providing a specific service to this pedestrian. So the UAV could be streaming some form of content, such as it could have a video camera equipped, and it could be recording a specific event which is going on, and the user can connect directly to that UAV in order to stream that down to their phone. It could also be used to provide connectivity to this specific pedestrian as well, and we'll explore that in more detail later on. Now, all three of these specify direct and indirect communication to the other party. The indirect communication can be utilized through A2N, and this is aircraft to network. So here we're talking about this UAV communicating directly to the 5G system in order to communicate with another party that is connected to that 5G system as well. So in terms of A2X, we have specific policies which can be utilized. Now, A2X covers 4 domains for these policies. So these are going to be referred to as A2XP, A2X policies. Now, we have policies surrounding specific A2X communication. So how is this device allowed to communicate? And that can be specified by the 5G system. That can be communicated down during registration. This is how you're allowed to communicate. We're also allowed to discuss the broadcasting of the remote identifier for that specific UAV. So when a UAV is being used, it's going to be constantly broadcasting its remote ID. And this is for identification purposes. Is that drone allowed to be where it is? And it's also to support communication as well between different devices. We can also support direct, detect, and avoid. And that's what we discussed previously, communicating with different parties to support the reduction in collisions and support avoidance. Finally, we can also apply policies for direct to C2 communication. So with direct C2 communication, we're specifying exactly how this device is allowed to communicate with other devices. Now, to summarize, we've explored A2X, we've explored the different domains which it supports, but there are also additional domains which are non-official. So we have A2S, which is aircraft to space. We've got A2G, which is aircraft to ground. So this could be a ground station which is being utilized. And finally, we've got A2V. So this is aircraft to vehicle. So that could be communication between specific drones and autonomous vehicles to support decision making. Within this section, we're going to be providing a brief outline of specifications which are utilized in order to support uncrewed aerial systems across a 5G system. Now, to begin with, we've got the technical specification 22.125, and this is to provide information about how UASs can be supported in 3GPP. So here we're going to be seeing specific architecture enhancements which can be utilised in order to support uncrewed aerial systems within a 5G environment. Moving on from that, we've got technical specifications 23.255 and 23.256. Now, these are focused on application layer support, so communication across the 5G system between the UAV and a UAV controller, for example, or that UAV and the UTM, US Traffic Management System. In addition to that, it provides information about connectivity, about identification, and about the tracking of that specific UAV within that UAS. Moving on from that, we've got TS 23.287. Now, this is 5G system architecture enhancement for V2X, but we previously discussed about how a lot of the A2X enhancements which are being utilised are based upon the V2X specifications. So if you go through the A2X specifications, a lot of the references within there will say, whenever you're looking at this specific process, such as registration, look at the V2X specification that we've got here and just replace the word V2X with A2X. Now, on top of that, we've got two technical specifications for A2X protocol aspects. So we've got 24.577 and 24.578. Now, these focus on the protocols which are being utilised in order to actually support A2X communication. And finally, we've got a specification here which is LTE long-term evolution or 4G focused. Now, this is LTE enhancements for aerial vehicles. So this is how support can be provided with 4G for uncrewed aerial systems. Now, in here we have discussions around mobility, around tracking, around handovers of UAVs. That's all supported within that specific technical specification. On top of the 3G specific or 3GPP specific technical specifications, we also have general specifications which are utilised as well. So here we've got a subset of specifications which cover drone communication, they cover drone mobility, for example. So to begin with, we've got ASTM F3411-22A. Now this is really providing sort of the capabilities that a UAV is required to utilise. Next, we've got the ITU-T Y.4421. Now, This standard is focused around the end-to-end 5G architecture which needs to be utilised in order to support uncrewed aerial systems. Next, we've got GSMA's cellular connectivity guidelines, and within that there is a section talking about UAVs and the overall uncrewed aerial system. So it's providing specific mechanisms which can be utilised in order to provide accurate location-based information on specific UAVs and to support mobility and tracking. And finally, we've got this GSMA leveraging 3GPP cellular network mechanisms to support UAS operations. And this is providing all of the different capabilities which a 5G network offers in order to support uncrewed aerial systems. So this can be that location tracking, this can be mobility-based information, this can be that handover-based information, but it could also be that UTM querying the 5G network in order to retrieve this information as well, or to provide information to that 5G network. So in this section, we've seen a range of different standards and guidelines which support uncrewed aerial vehicles. Now, it's important to know that these standards and guidelines may vary depending upon the region you are in.